So today we're going to be talking about orbitals, and orbitals is a bit of a sensitive topic, especially in chemistry due to the fact that it's a very advanced concept, but in regular chemistry, when we're learning normal chemistry, it actually isn't that complicated, but due to its complicated origins, it may seem a bit difficult. So orbitals. What are orbitals? And orbitals was first introduced by this mathematician called Heisenberg. And Heisenberg discovered through mathematics and proofs that no matter how hard we try, it is impossible to exactly pinpoint a location of electrons in an atom. So this famous proof that proves that electrons cannot be determined by location precisely is called the Heisenberg's principle, or more often known as Heisenberg's uncertainty principle. And this states that it is impossible to determine the exact location of electrons. And this caused a lot of problems because before Heisenberg, scientists and chemists used the Bohr model, but after Heisenberg proved that the Bohr model wasn't actually accurate or accurate enough, scientists and chemists developed this new thing called orbitals. And what orbitals are is quite similar to electron shells or orbits. And just to eliminate any confusion, if this is an example of a helium ion, this would be orbits or electron shells. But orbitals are a complete different story. They are very different from orbits. And an easy way to understand orbitals is by a quick analogy. So let's say that we have a character named John, right? And this character named John is a friend of ours. But even though me and John are very close friends, it is very difficult for me to know where John is exactly every second of the day. In fact, it's impossible for me to know where exactly John is throughout the day. So, although we don't know where exactly John is throughout the day, we do know 3 locations that he often goes to. First of all, we have his school. So let's say that there is his school, and there is his house, and there's his house, and there is his friend's house. Alright, so let's draw this a bit different. Friend's house. Oops. So let's say that our friend John mainly goes to these 3 areas, alright? His school, his house, and his friend's house. So we can guess that although we can never know and it's impossible to know where John exactly is, we can figure that he is in this area, or at least one of these 3 areas. Alright. And we can assume that although he might go somewhere else very occasionally, very rarely, most of the time, 99% of the time, he is within this area, this perimeter, this general perimeter. And this is basically orbitals. So the analogy was that our character John stood up or standed for electrons, and this area, this general area of where we guessed he would be like an orbital. So an orbital is where scientists, or where we can guess the electrons are. We aren't completely sure that they're in this area, but we believe that there is a high chance for these electrons to be in this area. So that is the general idea of what orbitals are. Now, there are 4 types of orbitals. So first of all, there is the s orbital, there is the p orbital, there's the d orbital, and there is the f orbital. And taking a look at this graph, you might be slightly overwhelmed by all these complex geometric shapes, these 3D shapes. But actually, in reality, you don't need to know any of these. This graph, the only reason this graph is here is to give you a general idea of what orbitals are. Because orbitals is a complicated subject, as you can see from this graph, but in high school chemistry, especially in regular chemistry, we don't need to know very deeply about orbitals. We just need to know that there are 4 types: S, P, D, and F. As you can see that as we go down the list, the types of orbitals increase. There's 1 type of s orbital, there are 3 types of p orbitals, 5 for d, and 7 for f. Now, because this graph is quite overwhelming, if we just slide over, let's just summarize this. So basically, orbitals are areas that we guess or we presume the electrons would be. Now there are 4 types of orbitals. S, as you can see in this graph, the very most simple one, P, D, and F. But for S, there is only 1 type of orbital. There is only one orbital. So S has 1. On the other hand, P is slightly a more complex shape. And there are 3 total types, or 3 areas that presents the orbital P. Now, you don't need to know what exactly it means for P to have 3 orbitals. You just need to know that P has 3 orbitals. You just need to memorize this. And a good way to memorize all these numbers for their corresponding orbitals is that as the list goes down, we can see that it is just the first 4 odd numbers of natural numbers: 1, 3, 5, and 7. And so you just need to know that there are 4 types of orbitals, and S, P, D, F, and they each have 1, 3, 5, 7 orbitals, or spaces, that we presume electrons would be. Now, taking a look at an example. As we learned before, we learned that, so if we say that this is the atomic nucleus, and these are orbits, and or so-called electron shells. These numbers here that indicate which lines the orbits are, these guys are called main shells. And this is just another name for electron shells, but we commonly also call them main shells. Now, in every main shell, there are orbitals. As you can see, S is the smallest one, P was the second smallest one, D was the third smallest one, and F was the biggest one. And these shells are called subshells. So in every main shell, in every electron shell, as we see here, there are orbitals. As you can see in n equals 1, the first electron shell, or the first orbit, there is 1 orbital of 1s. Now in the second main shell, in the second electron shell or orbit, or whatever you want to call it, there are 2 orbitals, 1s and 2p, and the list goes on. And you might be wondering, how do we memorize this? How do we memorize which orbitals are in certain shells? And it might be when first looking at it, it might be a bit overwhelming, but there's actually a very regulated pattern for this that barely has any exceptions. And we're going to be covering that in the second part of this lecture, where we will cover how we can find patterns with orbitals and find the electron configuration for any atomic or any atom in the periodic table with ease.